Hello everyone. If you are following my social media page, then you must remember that sometimes back I shared this sketch. So today I wanted to just discuss about this sketch. I wanted to make you understand what is this sketch and what was my purpose to create this sketch. So this sketch I mainly created to make you aware of most of the part of the embedded software development. This does not contains anything related to the embedded hardware development. Also, this is only for the microcontroller. As you know, in the embedded we have majorly two kinds of systems. One is the based on microcontroller, which we often program using C language. One we have microprocessor, usually your embedded Linux system, QNX system. Majorly those are your C++ and other high level languages. How I have done is I have started from the basics, okay, from the core, and I have gone till the industry level standard. Now I will zoom it. So if you will see the core part, in the core part we have the bare metal programming, register level programming. So if you are following me, then you know we are about to complete our introduction playlist of the bare metal programming. Definitely advanced concept videos will also come later part. If you will follow that playlist, at least you will get a fair idea what is the bare metal programming, what is the register level programming. Basically I will put the playlist link in the I button. So in the core we have the bare metal programming or the register level programming. Directly we modify the microcontroller registers. The bare metal program will be everywhere. Whatever the code we will write or anything, okay, that will be bare metal. We will not use any IDE or other supporting libraries. So for example, in the STM32 we have HAL library, you know, hardware abstraction layer library. After the bare metal programming we have microcontroller peripherals. It's not like, you know, you can do everything using the software. For lots of work we need the hardware support. After this we have the innermost circle where I have placed all the microcontroller peripherals. So some of the peripherals you may identify like ADC, analog to digital converter, DAC, digital to analog converter, MPU, memory protection unit. But yeah, we have a lot of peripherals, especially when you will use the high-end microcontrollers. Generally we use in the safety critical domains like automotive domain or in the aerospace. So there you generally we use the high-end microcontrollers. Those microcontrollers are very powerful and they have lots of features. They have lots of peripherals. So what is the peripherals? Peripherals are nothing but some hardware modules embedded into the microcontroller, and every hardware module have a distinct feature. For example, if you want to monitor a temperature, we use the ADC. We can use the PWM to control the stepper motor, some BLDC motors, servo motors. We can use MPU to restrict memory access of critical region. Now after the microcontroller peripheral, the second circle is about the softwares. What are the different software stacks we have? The most common is the application. We will have the software which represents some feature. So suppose you have a temperature controller in the AC. So there will be one software which will be keeping track of the outside temperature and it will be controlling the cooling of the AC. So we can have one software component for that feature. So that generally we call the application software. Then after the application software component, we have the bootloader. Bootloader also you will find in most of the industry projects. The main use of the bootloader is to update the application. So if you want to update the application, we must have a bootloader. Now why we want to update the application? We want to update the application mainly because of two reasons. First, either we have improved something in our software. So some new features we have added. So let's take example of vehicle. In the vehicle, parking sensors are there, right? Whenever any object comes in some proximity, in some range, so it started beeping. Let's say you updated your software, okay, and now with the beep sound you are showing the distance also. What is the distance of the object? So that is a new feature we have added. This is one reason why we update our application. Second reason could be let we fix some bug. Say in the same example, let's say the parking sensor is detecting some object which is very far and it is giving the beep sound, or maybe some object has came very close and then it is giving the beep sound. Means it is not working properly. So there is a bug in our application or in our software. So to fix that bug we need the bootloader. Then we have the functional safety requirements. So what is the functional safety requirement? So every industry will have some functional safety requirements, especially the industry which is very safety critical, automotive industry or the aerospace, defense, medical domain, okay, all these industries, they will have some safety critical requirements in one way or another way. Because whatever the embedded systems we are going to use in these projects, what happens if something go wrong, okay, what happens if something fails? Even if something is failing, then the failing should also be controlled. It should not be a uncontrolled fail. Our functional safety makes sure of this thing. For example, in the car, now we have the power steering. So even with the slight twist also, your steering, it will move basically. But in the old times, there was the complete manual steering. In that, driver has to put all the force to move the vehicle left or right. Nowadays, in the power steering, we use the electronics, we use the embedded system. What happens if that embedded system fails? So then we can switch the steering to the manual mode. So this is one solution. Or maybe we can have a backup module which will kick in when my primary system fails. So these kind of things generally we take care in the functional safety. So that's why in all the safety critical domains you will have the functional safety requirement. Then we have the RTOS. RTOS is nothing but the real-time operating system. Many of you must have heard about the RTOS. Many of you may have worked also on the RTOS. RTOS is something which takes care of the resource sharing in the microcontroller and many other things it does. And how RTOS is different from a full-fledged OS. The full-fledged OS we have like Linux or the Windows. So RTOS is a real-time operating system. Means RTOS guarantees the response within a fixed time. Many other differences are also there, but yeah, those are the secondary. After that, we may have a cybersecurity stack also. Usually, when you will be dealing with the high-end microcontrollers, right? The Infineon controller for the automotive domain, or I don't know, maybe RH850 and those microcontrollers. So there you will have a separate processor core. Usually the M0 core will be there to run your cybersecurity related requirement softwares. Then some separate hardwares will be there, like the crypto accelerators or Mac related job accelerators. Most of the time that core will have its own RAM, it will have its own flash memory. In that case, you will have another software stack, that is a cyber security. Of course, in the STM32F407 we don't have this luxury, so we will have to implement some cyber security related requirements using the existing peripherals or resource whatever we have, and we need to run those cyber security related things as a part of application software stack. So cyber security, I believe most of you know, and most of you must have heard about the cyber attacks. So if any system which is connected to some network, many people have the access to that network, then that system is vulnerable basically. Anyone can initiate a cyber attack on that system. Nowadays, if you will see, very advanced vehicles are coming. Those vehicles constantly they are connected with the internet. You can update the softwares. We have the FOTA, right? A flash over the air. You can reprogram your whole system. So maybe some hacker can hack your system and they can install the malicious software in your system, or maybe they can steal your data. Even it can go up to such extent that suppose your car is running on the highway and they can shut down all the functions in your vehicle. Eventually you will not be able to control your vehicle and in a highway in a very high speed, and you will meet with the accident basically. So this much dangerous things can happen. In this kind of scenario, our cyber security related requirements and cybersecurity related implementation and all those things, softwares comes into the picture. So in cybersecurity, we have the AAA, so authenticate, authorized, and then accounting. So authenticate means whoever is accessing the system, whether user is authenticated user or not. Usually the authenticated user will have the proper keys and all, everything. And then authorization means the user who accesses the system, what is the authorization level of that user, whether the user can access everything or some restricted things cannot be accessed with this user credentials. Then the accountability, whenever the user accesses the security levels, what the user is doing, keeping the log or keeping the detail. So these kind of things we take care in the cyber security related requirements. So yeah, if you are working in any of the industry projects, then you must be seeing all these software stacks. Next circle, we have different industries. There are lots of industries which uses the embedded system, but I have listed down their top 5 industries which uses the embedded system very extensively. Usually these are the industries where you will often find a job. These are the bigger industries also. So first one, if you will see the consumer electronics and IoT. Consumer electronics, like we know, like TV, fridge, washing machine, these are the consumer electronics. And nowadays our consumer electronic, it is becoming smart. It is, inbuilt IoTs and everything is coming with this. Then we have the industrial automation and robotics. Industrial automation mainly we use in the manufacturing and the packaging. So we set up big machines basically, which automates the task. So no human intervention is required. Machines do all the steps in the manufacturing by themselves, and they give the final product. So that is the industrial automation. And then we have the robotics. Robotics is a well-known domain, right? So we have different kinds of robots: movable robot, immobile robots, humanoid robots. There also we use the embedded system very extensively. Then we have the medical devices. Most of the medical devices what we see, they are mainly the embedded systems. So whether you are using something to test the vital details of a patient, or you are operating something, or you are in the lab, you are doing some test, some blood test or some test. Okay, so all of these places we use the embedded systems. Then we have the aerospace and defense. Aerospace is mainly your flights. Okay, so aeroplanes. In the aeroplanes, somewhere between 400 to 600 different subsystems will be there, which is based on the microcontroller basically. And all those subsystems, they communicate with each other, and they make available all the features and functionalities and everything. Okay, they keeps your aeroplane flying basically. And in the defense, we know we have like missiles, we have the rockets, we have the satellites, and all those things we have. So there also we use the embedded system very extensively. After that, we have the automotive domain. Automotive domain means mainly the cars and bikes. In the automotive domain also, we have lots of microcontroller subsystems. In one good car, easily there will be around 200 to 300 different subsystems will be there based on the microcontroller. Okay, so any features, power window feature, auto rain sensing wipers, okay, even your instrument cluster, your infotainment cluster, okay, all those things are embedded systems. Your instrument cluster, most of the time it is based on the microcontroller, and your infotainment cluster, which has that infotainment display on, that is most of the time based on the microprocessor. These are some major domains we have where extensively we use the microcontrollers. Now after the domains, I have listed all the standards and all the frameworks which we follow to develop the software in that particular domain. So it's not like you can develop the software however the way you want. For the software development in every industry, we have the separate standards, we have the different frameworks which we have to follow, the processes which we have to follow, and those frameworks, standards, and those processes make sure that our software is safe and our software can go into the safety critical systems. Apart from these standards, then we have lots of different kind of testings are also there. So in the upcoming videos, we will deep dive into each and everything. We will see each and every peripheral, what is the functionality of that peripheral, what are the use case we have for a particular peripheral, and then we will see what all these software stack does, and then we will see the domain specific standard. In this series, we are not going to develop any software, or we are not going to see any code, but the idea here is to make you familiar with the things which you are going to see very often in your career, in your professional career. So this is very helpful for someone who is in college, okay, or someone who is a fresher, or any other individual who is just curious enough to know embedded systems. So see you in the next video. You can share this video to anyone who can get some benefit, and stay tuned for upcoming videos.